Everyone, welcome back to another exciting day in mathematics. Warm-up 53 is on the screen. Let's get started, please. How's everybody doing? How's your break? Good? All right. Well, we're back. Oh, yeah. Thank you. Good morning. Focus, people, focus. I'm going to give you guys about 6 minutes. By now, we should be experts at those. Copy it. All right, here we go. Being that it's Monday, I'm going to go over this one with the help of Miguel, since he was done a long time ago. Very good, Miguel. I see you. All right. Number 1, it says use 1 to 3 to evaluate the function. 1 to 3. So, question, do we include 1 and 3? No, so what number am I going to use? 2, that is correct. So, let me zoom in. Now, some of you are like, I don't remember, Mr. Q. Look up. We said parentheses is not including the number, is that correct? Yes. However, bracket means include the number. Is that a good review? Yes? So if we go from 1 to 3, do not include 1 and do not include 3. So what am I going to use? I'm going to use the number 2. So with that said, to evaluate 2 in here, basically I'll just take f of 2 equals 2 plus 2 power. Because instead of x, I wrote 2. So that is 2 to the 4th power, which is 2 times 2 times 2 times 2, which is 16. Let's do that now for f of x base 10. This was base 2. This is base 10. So f of 2 equals 10 to the 2 plus 1, or f of 2 to the 10 to the 3rd power. 10 times 10 times 10, that's 1,000. Oh, yeah, we got this. Pretty good, yeah? All right, then we zoom out. Let's go do the transformation. So our transformation is for a cubic. Let me do that over here. So to graph f of x first, we got 0, 0, 1, 1, 2, 8, negative 1, negative 1, negative 2, negative 8. And it looks something like this. You guys remember that? Yeah? All right. However, they want us to transform it according to this. So which direction am I going to move that to? The little 3 outside the parentheses. Tell your neighbor which direction we're going to move that to, people. Which direction? All right, let's go with Leo. Which direction, Leo? To the right and up. So to the right, 2 steps and 1 up. So this point is going to be 1, 2 steps, 1 up. So it's going to be right there. This one, we move it right there. Okay. However, what does this do to the entire function, people? It flips it. That is correct. So instead of going like this, it's going to go like that. Next. Now these we've been practicing before even we went to break. So I'm pretty sure that turkey or ham or tamales, pozole or menudo hasn't gotten that information from your noodle. So tell your neighbor what you got for these 3, and then Miguel's going to enlighten us with these 3. What you get for 3A, B, and C. Tell your neighbor what you got for 3A, B, and C. All right, Miguel, what you get for 3A? All right, B. 1 and C. All right, so for 1A, we can't have negative exponents, so we send that to the denominator, and we change the exponent to a positive, and we put a 1 on the top. C, you distribute the power here and here. So that gives us 5 to the negative third power over b, negative 4 times negative 3, that's positive 12. However, can we have a negative exponent with the 5 to the negative 3? No, Mr. Q. So we send it to the denominator, 5 to the third power, positive, b to the 12th power, and what do we write on the numerator? A1. Last but not least, rewrite the last one. 7 to the x minus 2 becomes 7 to the x times 7 to the negative 2. Once again, can we have negative exponents? No, that goes to the denominator. The other stays in the numerator. So this is 7 to the x over 49. You get that, Miguel? Let's go. All right. So, zoom out. All right, do me a favor. Send me your warm-up. I want to see what you did. All right, we good? All right, copy the agenda. Warm-up 53 done. We're in the middle of rational functions. Tonight's home plate 6 problems, graphing only. But today we're going to move into a different type of rational, a little bit different. And you'll see that when we get there. Once again, warm-up 53 done. Rational functions. 6 problems for home plate for tonight. Now, by now, we should be experts at rational functions, right? Yes, Mr. Q, we even had a part A on quizzes. Oh, that's true. I need to update that on your Canvas today. Ooh-wee. All right. Everybody copy the agenda? Yes? All right, copy this code to access your home plate for tonight. LWG5Q, write that down. LWG5Q, write that down. LWG5Q. Okay, we good? Once again, tonight's home plate, those 6 problems right there. All right, and you don't need a Cornell note. We're going to write the objective at the bottom left of your graph paper. So make sure you have a graph paper in front of you. We can go straight into that. Give you guys some time to pick that up. All right. All right, here we go. Our objective for today, I can write, solve, and graph rational functions. I can write, solve, and graph rational functions. So before we continue, remind your neighbor whenever somebody says rational functions, what are 2 critical attributes rational functions come to mind when you're thinking about that? What 2 things do rational functions need to have? Tell your neighbor, please. 2 things rational functions need to have. 2 things. All right, write them on the screen where it says critical attributes. Write me 2 things, important things rational functions should have. Yeah, 2 things that it needs to have is a fraction and an equal sign, yes? Yes, Mr. Q. All right, good. So, I gave you guys steps right before we left for vertical and horizontal asymptotes. And then from there we went to the different type where we needed to do long division. Then from there we went to write an equation from the graph. We went and started with our general rule. And now our general rule looks like this. Remind your neighbor what K does, H does, and what A does. Talk to your neighbor. What does K do, H, and A? Remind your neighbor, please. All right, let's see. Looks like Leo's got it. Leo, what does K do? Up or down, and also it's what? What kind of asymptote? The vertical. That is close. Horizontal. That is correct. What does H do? Let's go with Daniela. What does H do? Left and right. That is correct. And what kind of asymptote is that? Vertical. Okay. How about A? What does A do to the whole thing? Go with someone different. Let's go with Leo. Stretches or compresses. That is correct. Okay. And once again, we're in the middle of vertical and horizontal asymptote. And just to double check, our K is our horizontal, which looks like that. And our H is our vertical, which looks like that. Is that correct? All right. So, we did some of these. Very simple ones. And what did we do first? We graphed what, everyone? F of x. And then from there, we graphed that. So let's do this one together just to get our brain going once again. Get your graph in front of you. Copy that one. Example Q. Example Q. Example Q says graph g of x equals 1 over x plus 2 minus 3. So step 1, we always graph f of x equals 1 over x. Okay? So, to this one, we know that our HA, or f of x, is 0. So our horizontal asymptote goes like this, at 0. And since there's nothing next to the x, our VA is x equals 0. That means vertical, going up and down, or straight down, like so. There it is. And to graph this one, remember when we did the table, we had 1 point here and 1 point here. Okay. Is it coming back? Yes? All right. Next. Tell your neighbor where we're going to move all of that according to this. Talk about your neighbor. Where are we going to move that according to that? All right, let's go with Natalia Castro. Where are we going to move that tail? Left and 3 down. Hands if you agree with that. That is correct. 2 to the left and 3 down. So 2 to the left, 3 down. So my new vertex, or my new point of origin, is there. So that means my horizontal asymptote is right here. My vertical one right there. So that means my new points are 1 up, 1 to the right from here, 1 down, 1 to the left from there, and there you go. All right, let me send you the screen so you can send me your notes. Copy that one, please. Example 1. Graph g of x equals 3x minus 4 over x minus 1. Once again, we should be able to do these by ourselves, but I'm trying to go over these together with you because I'm pretty sure you ate a lot of tamales or whatever it is you ate over the break. And maybe your brain is going slow. What's that? Bam, I did not. I had turkey, I had ham, I had some potatoes with called confetti potatoes, something like that. I forgot. Ah. All right, so first, I want you to graph for this one, f of x equals 1 over x. And then from there, see what we can do with that. I'll give you guys a head start. All right, here we go. So, f of x, once again, the HA, it's at 0. VA is at 0. 1 point there. 1 point here. But now we need to move it according. You're like, oh snap. That looks different, Mr. Q. What do we do here? Let's see. Let me go with someone different today. Let's go with Leo. What do I do with this? Everyone, what do we do with that? Long division. Bah. 3x minus 4 divided by x minus 1. So, how many times does that times x give us that? That's 3 times. 3 times x is 3x. 3 times negative 1 is negative 3. Subtract. Distribute that here and here. These cancel. We're left with negative 1 as remainder. So far so good, yes? Is it coming back? So the answer is 3 plus the remainder of negative 1 over x minus 1, which is this part. However, can we leave it like that? No. Reminder, tell your neighbor what to do with those numbers, please. The 3 goes where? At the end. How about this negative? Goes to the front. So we got negative 1 on top, x minus 1, and at the end we put plus 3, and all that equals g of x. So now that we have that, where are we going to move this to? Leo, pass them one. Right 1 up 3. So let's do that. Right 1 up 3. So our new vertex is right there. And our points should be where? Here and here, technically. However, what does this do, everyone? Flip them. So we bring this one on top over here, and this one below the asymptote. And there you go. All right, from 1 to 5, how come are we up to right there so far? Yeah, we should be at 5, right? Okay, y'all ready? Because we're about to crank it up. Oh, yes. However, let me send you a screen so you can send me your notes. All right, which brings us to this one. Look up. Copy that. Example number 3. Go to, if you have the big graph, let's do this one on the big graph. Copy that on the top left. It says, rewrite the function and graph f of x equals 1 over x squared. Focus, please, because this one's a little bit different, and I want to make sure we got this down. It is different. Tell your neighbor what's different on this one. Oh, ooh. Oh my goodness. Now look at it. Look at it compared to the other f of x's that we graphed. What's different on this one? Has an exponent of 2 on the denominator. You guys see that? Let me go back to the previous one. Look up. Watch. Look at the previous one. What was f of x? Look how f of x looks. You guys see f of x over here? Look at f of x now. The little squared, right? All right, so with that said, to graph that, I want us to get a table going. X, f of x, yes. And we're going to use -2, -1, 0, 1, 2. All right, so I'm going to use this to substitute our x value. So I got 1 over parentheses squared. So let me zoom in. So my first value is -2. 1 stays the same. What is -2 squared? -2 times -2 is 4. So this is 1/4. Let's do that again now for the next value. 1 over parentheses squared. My next value is -1. -1 times -1 is 1. 1 over 1 is 1. Let's do it again now for 0. 1 over 0. Is this true? Could we have 0 in the denominator? No. You write undefined. Undefined. Next, put a 1 underneath. 1 over 1 squared is 1. That's still 1. And last but not least, 1 over blank squared, that's a 2. So this is 1/4. All right, let's graph that. Let me zoom out. All right, so being that it's f of x, we need our HA, which is still what? 0. Our VA, x equals, is there anything next to the x here? No, so it's still 0. So now that we have our asymptotes ready, let's graph our points. Here we go. -2, 1/4. -2, 1/4. -1, 1. And now the next one is undefined, so that means we're done with the left side, so we graph our little curve. Go to the other side. 1, 1. 2, 1/4. All right. So, what do you guys notice to the original f of x equals 1 over x? Nope. Isn't the other one supposed to be down here? But now it's where? Up here. And they're back to back. This kind of graph, whenever you have an exponent on the denominator, focus, I call this graph the J-low graph. J-low. See the J and the L right here? J-L? No? Right here. You guys don't see it? J-L. No? All right. So look up, guys. Write your utensils down. Look up to the screen. Let me just clarify this to make sure we got it. Focus, please, because we're about to get into these, and I want to make sure we got these clear. If I was to ask you to graph f of x equals 1 over x, we know we start at 0, 0, 0, 0, 1 point up and to the right, 1 point down and to the left. Is that correct? Yes, Mr. Q. Do we need a table? No. I'm going to use now blue for this next parent function. 1 over x squared. How do we graph that without any table? Well, at 0, 0. Again, 0, 0. However, 1 up, 1 to the right. And then instead of going 1 down, 1 to the left, I go 1 up and 1 to the left. You guys see the difference now? It went from these two to these two. We good? All right. With that said, the rest we're going to graph without a table. So copy this one, example number 3. Example number 3. 3Q, my bad. Says, rewrite the function and graph g of x equals 1 over x minus 5 squared minus 3. The small one. All right. So right away, what do you guys notice on this one? That it has a what on the denominator? The exponent. Is that correct? So that means we're going to graph f of x equals 1 over x squared. So let's start with this. So we start at 0, 0. My asymptote. That means my HA, there it is. My VA also at 0, 0. My point, 1 up, 1 to the right. And my other point, tell your neighbor, where do I place the other point for that one? All right. Where do I place the other point? Let's go with German. Go. You said negative 1 and 1. That is correct. So we're done with this f of x. So now, look, I'm going to use my Jedi Master skills to get you guys triggered in your brain. Ready? Tell your neighbor where we're going to move all this according to that. Where do we move that to? All right, let's go with Eileen. Eileen, where do we move that to? Five to the right and down 3. Hands if you agree. That is correct. So 5 to the right, down 3. So our new vertex is there. My asymptote is here. The other one is here. So now that we have our asymptotes there, tell your neighbor, what 2 points am I going to use? Where do I place my new points? Where do I place my new points? Eileen, pass someone. Leo, where do we place our new points? We, 4, negative 2. 6, negative 2. Hands, have you got that? That is correct. So basically, we just moved this over here. So what's the only difference from what we were doing before? Well, now that we have a square, the graph, we have a point above and the other point above, and we move the whole thing to whatever the transformation. Let me send you the screen so you can send me your graph. Next, copy this one, example 3 mega Q. And it reads g of x equals negative 1 over x plus 3 squared plus 2. right? What's the first thing we do? Tell your neighbor. First thing we do. Tell your neighbor, and then Scarlett's going to enlighten us. First thing we do. Tell your neighbor, please. Then Scarlett's going to enlighten us. All right, good conversation. So Scarlett, what do we do? She said graph f of x equals 1 over x squared. Parent function, is that correct? Yes, Mr. Q. And she said horizontal asymptote at 0 and vertical asymptote at 0. And what points do I use, Scarlett? Negative 1, 1. And 1, 1. Okay. Hands if you got up to right there so far? Okay. However, don't we need to rewrite the transformation before we do the movement? Tell your neighbor what we need to rewrite on this one. Pass someone, Scarlett. Natalia. Which one? Castro. What do I do? Uh-huh. Where I move that to? Yes, to the front. 1 over x plus 3 squared plus 2. So now, where do we move that to? Pass someone, Natalia. Leo. Up to left 3. So up to left 3. So my new asymptotes are right here, here, and here. Now, before you give me the points, just remember this one does have a negative in front of it. So tell your neighbor where you're going to place your new transformed points, and then Leo's going to pass someone. Tell your neighbor where do we place those new transformed points. Leo, pass someone. Julian, give me the points. Where do I place them? Negative 4, 1. And negative 2, 1. And that is correct. Instead of going upward over here, they came this way because they flipped because of that. From 1 to 5, how comfortable are you with this so far? Where are we at? Yeah, 5 4s, 5 4s, okay. I'm going to send you the screen. You can send me your work. Example 3 super Q. Copy this one. This is going to be a doozy, but it's easy. No, should I say my words? Tweezy. It's tweezy. G of x equals negative 2 over x squared plus 8x plus 16 plus 7. Write that down. G of x equals negative 2 over x squared plus 8x plus 16 plus 7. All right, tell your neighbor really quick the very first step. What is the first step for all of these that we've been doing? Very first step. All right, good conversation. Let's go with Sarah. What is the first thing we do, Sarah? F of x, that is correct. F of x equals 1 over x. X squared. Oh yeah, that's true because this one, look up, has a squared. Yes. So at 0, our HA, our VA, and what are my two original points? Kiana. What is it? Negative 1, 1. And 1, 1. Okay. However, doesn't this look kind of weird? Yes, Mr. Q, we need to rewrite it. Okay. So, let's see. G of x What goes where? Tell your neighbor to get started. What goes where? -2 in the front, okay. -2 in the front, yes. This one goes in the front. +7 at the end, is that correct? But doesn't this look different? Let me go back to the previous one. Look at the previous one. It's supposed to be in parentheses squared, is that correct? So question, what does your brain want to do with this? Think about it. What does your brain want to do with that? How about yes, Power Rangers. So we got 16 on top, 8 below. What two numbers multiplied gave me 16 that when you add them give us 8? 4 and 4. Or in other words, x plus 4 what? Squared with a 1 on top. And fuego. So with that said, tell your neighbor where we're going to move those points or all of that to. Where do we go? 4 left and 7 up. 4 left, 7 up. So we got our horizontal over here, our vertical right here. Now technically, look up, we have a point here and here. However, tell your neighbor what happens with that. Tell your neighbor what happens with that, and then Miguel's going to enlighten us. Talk to your neighbor what's going to happen at the end with that -2 for these 2 points. These 2 points. All right, Miguel, what's going to happen at the end? They go down or you flip them. So instead of here, you bring them down here. And instead of being 1 step away from the asymptote, how many steps, everyone? 2. So instead of here, we go here and here. All right, let me send you the screen so you can send me your notes. All right. So from 1 to 5, how comfortable are you with this so far? Where are we at? 4 5s, 4 5s. Okay. So now, look at the assignment for tonight. Is there anything up there that we did not cover? Look at it. No, pretty much everything, right? So that's going to be for tonight's home play. I'm going to stop right there. Those of you following on YouTube, make sure you put in some practice. See you guys next time. Peace.